This is the Pre-Calculus Honors Semester 1 final review. I'm going to work on numbers 1 to 12 on the review. Number 1, graph y equals 3 raised to the negative x. Identify its domain and range. I assume you can all graph this on your calculator, and you would see something that looks similar to this. It's just, it would look like that. Some of the ordered pairs that this particular graph would go through is, it would go through 0, 1, because anytime you raise any exponential function to the 0 power, you're going to get 1. It go through -1, 3, because when you plug in -1 for x, you get those two negatives that make a positive, so you get 3 to the first, which is 3. 3 squared would be 9. I just didn't make an ordered pair that high. If you plug in -1 positive 1 for x, you get 3 raised to the negative first, which is 1/3. And then if you plug in 2 for x, you get 3 to the negative second, which is 1/3 squared, which is 1/9. For all exponential equations, their domain is going to be all real numbers. We have a couple ways of writing that. This is one of the ways of writing all real numbers. In interval notation, all real numbers is written like this. The final exam will have domain and range written in interval notation. But the range is not all real numbers because, as you'll notice by looking at the graph is only above the x-axis. Since the graph is above the x-axis and doesn't hit the x-axis, because the output of 3 to the negative x can never be 0, the range is y is greater than 0. In interval notation, that would be parentheses 0, comma, infinity. In problem 2, using the parent function f of x equals x squared, create an equation to show each transformation. So in order to show reflection on the x-axis, or we normally say reflection over the x-axis, the equation would be negative x squared. A horizontal shift 2 units to the left would be x plus 2 in parentheses squared. When we shift the graph left or right, you add or subtract inside a set of parentheses. Vertical shift 3 units down, that would be x squared minus 3. When you add or subtract from the original function, from the output rather than the input, you move the graph up and down. In part D, it says graph in the calculator to check. So since this is a multiple choice exam, if you're unsure if you've chosen the right answer, graph the parent function and then graph your choice to see if it looks like the parent function moved in that particular direction. Problem 3, given the equation y equals 2x squared plus 12x minus 6, find, the first thing they want us to do is to find the maximum or minimum and to find the range of this particular quadratic by graphing on the calculator. If you graph this on the calculator, you should see a parabola that opens up. Therefore, you would use the minimum function in order to find the minimum. The graphing calculator should tell you that the minimum is at -3, -24. The other thing we want to do is find the range. Well, once you know the minimum value, the range is going to be y is greater than or equal to the minimum. That's in set builder notation. In interval notation, that would be bracket -24, comma, infinity, parentheses. If this had been a maximum, the range would have been less than or equal to the maximum. In part B, it says rewrite in vertex form, y equals a x minus h squared plus k. So to rewrite this in vertex form, I'm going to start by taking the linear and quadratic terms, and we're going to add a new number to it to create a perfect square trinomial. But you can only create a perfect square trinomial if the leading coefficient is 1x squared. So I'm going to have to factor out that 2. Remember, when you factor out the 2, you have to factor it out from both terms. Oh, I should put another plus blank over here, because since we're adding a new number to the right-hand side, we're going to have to add a new number to the left-hand side in order to keep the equation balanced. The number that goes in the blank, you take the middle term divided by 2 and square it, is going to be 9. But the number that goes on the other side of the equation is not 9. Remember, we factored out a 2. Well, I got to multiply that 2 back in, and I get 18. The reason we created a perfect square trinomial is because it's easily factored into something squared. It's factored into x plus 3 squared. And then all I have to do is subtract the 18 from the right-hand side, and I get a negative 24. And there's my vertex form. The nice thing about vertex form is that h comma k is the vertex. So I want you to notice that the vertex is at negative 3, negative 24, which is the same as we got when we graphed it and used the minimum function on the graphing calculator. In problem 4, we want to create regression equations by using the regression functions on our graphing calculator. So in part A, we're going to create a linear regression with this table of data. The way this worked is you go to Stat, number 1, Edit, and that's where we're going to put information into our calculator. The X values always go into list 1, the Y values go into list 2. If you already have numbers in those lists, you can get rid of them by putting the cursor on L1, hit the clear button, and press down. And do that again with L2. If you accidentally press delete instead of clear, you would just go back into stat number 5, setup editor, enter, and it'll make the lists come back. Once you get the data into list 1 and list 2, then you go back into stat, but this time you arrow 1 to the right to calc, and you want to use number 4, linreg. If you have the new operating system, just hit enter twice and the equation will pop up. Or, yeah, the old operating system. If you have the new operating system, you'll probably have to hit enter a couple of times before the equation pops up. You should get y equals 1.59x plus 9.76, approximately. I just rounded it off to the nearest hundredths. Whatever is on the final exam for the multiple choice, you'll figure out which one's the right one. In part B, we want to do a quadratic regression. So you're going to start by putting this data into the calculator under stat, put this in list 1 and this in list 2, and then go back to stat calc, but this time use quad reg. This time it's going to give you an equation in this form, ax squared plus bx plus c. So the equation should be approximately 1.09x squared minus 5.02x plus 14.83. Number 5, the function y equals negative 1.2t squared plus 5.7t plus 16 models the height y in inches of your pet grasshopper's jump t seconds after it jumps. How high did the grasshopper jump? When did the grasshopper reach that height? Graph on the calculator and think about what you see. So when you graph this, first of all, you should know when you graph it, it's going to be an upside down parabola because the leading coefficient's negative. That means it's going to have a maximum value. So when you graph it, you want to find the maximum. Use the maximum function under the second trace menu. You should get approximately 2.37 and then 22.77. I just rounded to the nearest hundredth. Well, which one of those values is how high the grasshopper jumped? Well, the y-coordinate is how high he jumped. It's about 22.77 inches. When did the grasshopper reach that height? At 2.37 seconds. Problem number 6 asks you to find the solutions to 3x squared minus 21x plus 36 equals 0 by factoring or graphing. If you graph it, the solutions are where the graph hits the x-axis. That's probably the fastest way to do the problem on a multiple choice test. For factoring, I want you to notice that all three terms have a greatest common factor. They're all divisible by 3. So I'm going to take out a 3. And then I'm going to notice that the leftover trinomial is a simple trinomial. The two numbers that multiply to give you 12 but add to give you negative 7 are negative 3 and negative 4. The solutions are what you get when you solve that using the zero product property, so it's going to be positive 3 and positive 4. And if you graph it, you should see it hit the x-axis at positive 3 and positive 4. Number 7, what number would you put in the blank to complete the square? When we worked with conic sections, circles, hyperbola, ellipses, parabolas that open left and right, we did a lot of completing the square. We wanted to create a perfect square trinomial. The easiest way to do it is to take the middle term, divide it by 2, and then square it. It doesn't matter if you divide 22 or negative 22, because when you square the number at the end, it's going to become positive either way. And you should get 121. If I had asked you to write this in factored form, you would tell me that it's x minus 11 squared. Problem number 8 asks us to use the quadratic formula to solve negative 3x squared plus 2x is equal to negative 5. The reality is I would never use the quadratic formula unless the solutions are imaginary or irrational. I would always try graphing this first and see if you can't find rational zeros, because if you can on a multiple choice test, you're going to find the answers really quickly. But for the sake of argument, we'll do the quadratic formula, which is x equals the opposite of b plus or minus square root of b squared minus 4ac all over 2a. But you can only use it if the equation is an ax squared plus bx plus c equals 0 format, which it's not. Well, we can do that very quickly. All we have to do is add 5. And now I know that a is negative 3, b is 2, and c is 5. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. When I simplify this, I like to simplify in parts. So I simplify that because sometimes it says two negatives, in which case it would be a positive. So it's going to be negative 2 plus or minus the square root of. Now I'm going to evaluate the discriminant. That's the part under the square root sign. It's going to be 64 over negative 6. So negative 2 plus or minus 8 over negative 6. So one of my solutions is negative 2 plus 8 over negative 6, which is 6 over negative 6, which is equal to negative 1. The other answer is negative 2 minus 8 over negative 6. Negative 10 over negative 6 reduces to positive 5/3. Number 9, solve 25x squared plus 36 equals 0. And it even tells you it will be imaginary numbers. We didn't even need to tell you that. The fastest way to solve a quadratic that does not have a linear term is to first subtract the 36, divide by 25, and then you will square root both sides. You got your square root of a negative, which you know is going to be imaginary. And the square root of 36 over 25 is easy because it's just the square root of 36 over the square root of 25. You put a little I because you took the square root of a negative. And we always put plus or minus. If you forget about the plus or minus, Remember that all imaginary solutions come in pairs, called complex conjugates. Number 10, simplify each expression. Since there is an imaginary component on your calculator under second period, it's probably easiest to just do these problems in your calculator. Just make sure you always put all the expressions in parentheses. However, if you choose to do it by hand, you would subtract the real component, so 2 minus negative 3 is 5, and you would subtract the imaginary components. 7i minus 4i is positive 3i. For B, I think doing the calculator is the better option. However, you would distribute like you would with any other product of two binomials. You would get negative 6 plus 8i minus 21i plus 28i squared. Remember, I squared is negative 1, so that becomes negative 28. And negative 6 plus negative 28 is negative 34. And 8i minus 21i is negative 13i. In part C, in order to divide complex numbers, you would multiply the fraction by the complex conjugate of the denominator. The complex conjugate is what you get when you make the imaginary component the opposite sign. Notice nothing happened to the real component. The only thing that changed was that the imaginary component became negative 4i. And then you would do what we did in the previous problem, which is distribute. So I would get negative 6 minus 8i minus 21i minus 28i squared in the numerator. And the denominator, if you multiply it all out, because it's the product of a sum and difference, the middle terms will end up canceling. So you end up getting a squared minus b squared. You get 9 minus 16i squared. Well, this is going to become positive 28. This is going to become positive 16. So the numerator ends up being 22 minus 29i. And the denominator, 9 plus 16, is 25. If you do this in your calculator, it just writes the answer as 22 over 25 minus 29 over 25i. Same answer. So remember that I said that when you have a division of complex numbers, you multiply by the complex conjugate of the denominator. That means changing the sign on the imaginary component. So if the denominator is positive 5i, you would have to multiply by negative 5i. So you would distribute the numerator and you get negative 10i minus 35i squared all over negative 25i squared. Well, this becomes positive 35. This becomes positive 25. And since we always like to write the real component first, I would write that as 35 minus 10i over 25. And you kind of have to reduce everything, because remember I said this is the same as 35 over 25 minus 10 over 25i, and those fractions reduce. 35 over 25 reduces to 7 over 5. And 10 over 25 reduces to 2 over 5. But if you're able to do this on your graphing calculator, it'll give you this answer. Problem number 11, factor completely 2x cubed plus 20x squared plus 32x. First, I'll notice that there is a greatest common factor. All three of those terms are divisible by 2 and x. So if I take out a 2 and an x, I'm left with x squared plus 10x plus 16. And the trinomial left over, the two numbers that multiply to give you 16 but add to give you 10, are 8 and 2. So I would get x plus 8, x plus 2. There are two ways of attacking this particular problem. It says find the real / imaginary solutions of x cubed plus 2x squared plus 25x plus 50 equals 0, given that x equals negative 2 is one of the roots. That means if you were to graph this on your calculator, it hits the x-axis at negative 2. One way of doing this is because it's a four-termed polynomial, you can try factor by grouping. Factor by grouping works if you factor each group and what's left over in both parentheses is the same. So the first parentheses, you can take out an x squared, and you're left with x plus 2. In the second parentheses, you can take out a 25, and hey, look, you're left with x plus 2. That means the factors are x plus 2 and x squared plus 25. Well, we already know that using the zero product property, one of the solutions is negative 2. But the other two solutions are going to end up being imaginary, which if you graphed it, you would have already figured out. So if you solve this by setting it equal to 0, you're going to get x squared is equal to negative 25, and when you square root a negative, you're going to get an imaginary, and don't forget that it's plus or minus 5i. The other way of doing this problem is to use synthetic division. So you could have put negative 2 in your little box, and next to it the 1, 2, 25, and 50. You know that because negative 2 is a solution, the remainder at the end better be 0. So you get 1, and then negative 2, 0, 0, 25, negative 50, and 0, and you would be left with x squared plus 0x plus 25. You set it equal to 0, and you get the same thing you got here. And that's the first 12 questions on the Pre-Calc Honors Semester 1 Final Exam Review.